1, 2, 3, start. Hello guys, in this video we will be discussing one of the coding question called as a sort color, or in other words it is also called as sort 0, 1 and 2. Okay, this is the most beautiful question we come across, because in this question we are going to learn one of the most beautiful algorithm which is basically used to sort an array which contains three distinct values. Not only 0, 1 and 2, it can have 8, 9 and 10. It can have 4, 5 and 6. There are only three numbers inside the array, but those three numbers are distinct, means those three numbers are different. So say for example, in this given array there is only three distinct values, that is called 0, 1 and 2, and we need to sort this array, that is 0, 0, 1, 1 and 2, 2. So the question comes is, what are the different ways we can use to sort this array? So to know more about this, let's start this video. Okay, so when I look at this problem, the first solution comes in everyone's mind, not only in my mind, but any person who is watching this video. If you ask to sort any array, what comes in our mind? We simply need to sort an array. So the first method, I'm going to call it as a brute force. So let's call it as a brute force. Yes, of course it will be not an optimal and final solution for this, but just for the sake of understanding purpose how to optimize a given algorithm to minimize our time complexity, we are going to discuss about it. So basically what we can do is we simply take an array and go on doing sorting. Okay, now if you use a bubble sort, you can use the insertion sort, or you can use the selection sort. If you take this, the overall time complexity will be, of course, big of n square. Can we do it something better than this? Of course. Then we have a sorting algorithm called as a merge sort or the quick sort. Merge sort or the quick sort. So with the help of this, the overall time complexity will be for sure big of n log n, which is bit better than big of n square, right? N log n is better than n square. So this is the brute force approach. I'm not going to write any code for this because everyone are aware about such algorithm. So the second solution, can we do something better than this? Can we reduce the time complexity from n log n or from n square to big of n or less than that? So we call it as a better solution, right? We call it as a better solution. Okay, so when I discuss about the better solution, what comes in my mind is simply, it's a simple. What we can do is we will keep the three pointers or the three counters, I will say, that is count of 0, count of 1 and count of 2. So what we are going to basically do is start traversing the array and at the same time keep the count of occurrence of zeros, ones and twos, that is how many times 0 has occurred, how many times 1 has occurred and how many times 2 has occurred. So what we can do is we simply start traversing the array, that is from 0 to n minus 1, and simply what we will do is, that is a of I equal to 0, sorry, okay. Then simply what we can do is we simply can say the count plus plus, and if my a of I is equal to 1, if my a of I is equal to 1, then simply what I can do is count 1 plus plus. If a of I is equals to 2, then simply what I can do is I can simply increment the counter of 2. So from this loop what we have done is we have calculated the number of zeros occurred, number of 1 have occurred, number of 2 has occurred. So if we take an example, say for example here I am going to take a new example. Say for here if it's 0, 1, 2, 2, 1, 0. So in this, with the help of this loop, what we did is, with the help of this loop, what we did is we simply found number of occurrence of zeros, ones and twos. So from this, number of zeros occurred is equal to 2, number of 1 has occurred is equal to 2, and number of 2 has occurred is equal to 2. So we have found this. Now what we can do is, still the array is not sorted, then what we need to do is again start traversing the array. So again right from 0, where we can go is n minus 1. Since the index is starting from 0, that's why I'm taking as n minus 1. So what we can do is, since we know that we need to sort an array, we know that 0 must be present at the first part of an array. So what we basically do is, if my count of 0 is greater than 0, which means my array has certain number of zeros, then simply what I can do is simply I can put a of I equals to 0, and at the same time I need to decrement the counter of 0. The reason behind this is I'm decrementing the counter of 0 is because I have inserted the first 0 at its position. Don't worry, I'm going to give a dry run for this algorithm. First, once I finish the explanation of this algorithm, I will give you a dry run. So first we inserted the count of zeros, then what we do is else if my number of occurrence of 0 has finished, then what we can do is we can simply count if number of occurrence of 1 is greater than 0, which means my array contains certain number of 1 inside it. So again what I can do is I can simply insert a of I equals to 1, and simply I can decrease the counter by 1. Else if my number of occurrence of zeros and ones are both are finished, then simply which I left with, that is 2, then what can I do is simply I can go with I equals to 2 and count of 2 minus minus. So this is the most simple algorithm we can come across. If you talk about the overall time complexity of this algorithm, let me change my color. Okay. If you talk about the overall time complexity will be, the time complexity of this will be big of n. How will it happen? For this loop it will be big of n, and for this loop it will be big of n. So overall time complexity if I discuss, it will be big of n plus n, which is equal to big of 2n, which is nothing but big of en. Okay, let's have a dry run for this algorithm. Say for example, if we are given an array 0 1 2 2 1 and 0. Okay, now I find number of occurrence of 0 is number of occurrence of 0 are 2, number of occurrence of 1 is 2, number of occurrence of 2 is also 2. So what we basically do, say for example its index. So we are given an array this 1 2 3 4 5. Okay, 1 2 3 4 and this is 5. Okay, so what we basically do is we are running a loop from 0 to n minus 1. So right now I'm pointing here. Now I need to check, do I have the number of occurrence of 0 in my array? Yes, I have the 2. So what I do is I simply insert 0 and decrement the counter of 0 by 1. So 2 becomes 1, which means still I have the 1 0. Still I am left with 1 0, that is, say for example this 0. Now I point to increment this, and I need to check, do I have the occurrence of 0 in my array? Yes, there is one occurrence. So I simply put a 0 here and decrement the counter of 0 by 1, so it becomes 0. My pointer comes here. Now again I check, do I have the occurrence of 0 in my array? No. So if condition, that is this if condition will get false, then we come across this else if condition. Then what I need to do is I need to check whether do I have the occurrence of 1 inside my array. Yes, I have the 2 occurrence, so simply I put 1 over here and I decrement the counter by 1. So still my number of occurrence of 1 is 1. Then my pointer got incremented. Now again I check, do I have the number of occurrence of 0? Absolutely false. Again, then I come to the second if, do I have number of occurrence of 1? Yes, I have the 1. So simply I put 1 over here and then decrement the counter by 0. Then I come over here and I check, do I have the occurrence of 0? False. Do I have the occurrence of 1? False. Do I have the occurrence of 2? Yes. Then simply what I need to do is I simply put here 2 and I decrement the counter of occurrence of 2 by 1. Then my pointer comes here, and then again I check, do I have the occurrence of 0? False. Occurrence of 1? False. And occurrence of 2? Yes. Then simply I put here, which means we got a final result, that is we have sorted an array. Sorted an array. So this is the best. We can't say this is the best algorithm, but we can say a better algorithm than directly sorting an array. Now the question comes, can we do it better than this algorithm? Can we come across some optimal solution? Because in this array what we did is we traverse the array 2 times. Here it takes big of n times and here it takes big of n times. So is it possible to sort an array in just single traverse? Do we really need to sort the array using the 2 different loops? Absolutely no. So can we do it better than this? Yes. Now I'm going to tell you one of the best approach to sort an array which contains the 3 distinct values. And this name of algorithm we discuss is called as a Dutch national flag. This is the most important algorithm for any interview, any coding interview you are going. This is a most known algorithm. So what we are going basically do is, say for example, here are 0, 1 is equal to 2, 1, 0, 2. Okay, 0, 1, 2, 3, 4, 5 and 6. So what we are going to do with this algorithm? Here we are going to sort this array using a single loop. How we can do is, basically we are going to keep the 3 pointers, that is called start, middle and end. Now the start will be pointing this, my middle will also be pointing to this, and my end will pointing to the last part of my array. So basically we are going to deal with the middle element, which means what I need to do is, one thing is for sure, I know at the starting part of an array contains 0, middle part contains 1 and the last part contains 2. So overall we need to think is, what is my present element at the middle. So right now if I have the element at the middle at 0, what I need to do is, where I need to keep the 0, I need to keep the 0 at the starting position. So simply what I will do is, if my middle contains a 0, I will swap it with the starting position. I need to swap it with the starting position, right? Yes. Now if my middle contains 1, say for example my middle is pointing to here, then what I need to do is, we're assuming that the middle is the middle part of an array. If the middle contains 1, do I need to swap it anywhere else? Because the middle part itself contains a 1. So what we'll basically do is, if my middle contains 1, then simply what we'll do is, we simply increase the middle by 1, because we are not going to swap the middle element with anything. And the point is, if my middle contains 2, say for example my middle is pointing here, then what we need to do is, we know that the 2 should be present at the last part of an array. So simply we are going to swap the 2 with the end of an array. So what we'll do is, here we will swap the 2, right? So if my middle contains 2, simply swap with end. Simply swap with end. So this is the algorithm we are going to look at. It looks a bit complex right now for you, but once we start executing it, believe me, it is the most easiest algorithm. So let's think about this algorithm. How does this work? Now again I'm going to take about a different example. Now I'm going to look for, say for example I have here 1, 0, 0, 2, 1, 0. Okay, 0, 1, 2, 3, 4 and 5. Okay, now I'm initializing s to 0, middle is also to the 0 and end is pointing to n minus 1, which means end is here, my middle is here and my start is also here. So again what I need to do is, one thing is for sure, if my a of mid is equal to 0, what I need to do is, I need to swap with starting position of an array, that is a of mid. These things need to sort. Now what I can do is, since say for example here's right, then what we need to do is, we have already swapped 0 at the first position, then I need to increase the pointer, that is start and mid, by 1, because these two elements are already done. Say for example here it is 1 and my mid is pointing here. Now middle is contained 0, my middle is contained 0, middle element is swapped with this and 1 comes here, which means 0 should be present at the first part. We got the first part, then I must increase the pointer s by 1. So s comes here, so middle comes here. Hope so you got this. So that's why we are increment the pointer of 0, 1, and that's why we are increasing the pointer of start and middle by 1. Now the question comes, what if my middle element is 1? Middle element is my 1. So what I need to do is, right now say for example my middle element is here I already got a 1. So we know that at the middle part of an array contains a 1. So do I need to do anything? No. So if my middle part is 1, simply I need to increment the counter of middle by 1. Else if, which means my middle element is containing a 2, what I need to do is, I need to simply swap with end and simply decrement the counter of end by 1. We are not going to change the position of middle because we don't know what was present at the end. We know what was present at the middle, but we don't know what was present at the end. End might contain 0, so we need to swap that 0 with the start. So that's the reason why we are not changing the position of the middle. So let's have a dry run of this algorithm. Let's take a different example. 0 1 2 1 1 0 0 1 2 3 4 5. Okay, now my middle is here, my start is here, my end is here. Okay, let's check now. What is my middle element? 0. What I need to do is simply swap with start element. So this 0 will itself get swapped with this. Let me change my color. So this 0 will itself get swapped with this. So now increase the pointer of middle and start by 1. So here comes a middle and start comes here. Now what is middle? Middle contains 1. Okay. Now when the middle contains 1, I don't need to do anything because middle part of an array itself contains a 1. So I simply increment the pointer of m by 1. So m comes here. Now middle contains 2. What I need to do is I need to swap that 2 with the end element. So 2 comes here and 0 comes here. The end pointer is incremented by 2. This is the reason why I haven't increased or changed the position of middle, because we don't know what is the present at the end of an array. We simply took it to the middle position. Now middle contains a 0. What I need to do is I need to simply swap with start element. So it comes 0 and here comes 1. Again the s is incremented here and again middle is incremented here. What is middle content? Middle contains 1. Do I need to do anything? No. Simply take a pointer to forward. Okay, here. Now let's see. The end and middle are getting matched. Here end it was also here. End and middle is also getting matched, which means we have already traversed the whole array. And even you can see that here comes 0, here comes 0, here comes 1, 1, 1, 2, which means my array is already sorted. Yes. So this is the algorithm we are looking for. The overall time complexity will be its big of n because we are having the single traversal for this algorithm. Let's take a code for this. So this is the code I have wrote. In this I have initialized the start with 0, middle with 0 and end with num size minus 1. Now my end should be less than equal to end, which means I don't need to traverse the whole array. I need to traverse it till my middle element and end matches each other. As I told, if my nums of mid is equal to 0, simply I need to swap with start and increase the pointer of both start and mid by 1. If my middle element is 1, then what we need to do is we don't need to do anything because the middle part of an array itself contains a 1. And if there is no 0 and if there is no 1, which means the only element which I left with is 2, and what I need to do is I need to simply swap that with end of an array and decrement the size by 1. So this is the problem we will discuss in this video, that is sort color. You must try this. The link of this problem will be given in the description box. Give a try to this problem. Till then, have a happy coding.